Hello, everybody. My name's Tom Haddon, and I'm here to talk to you about Terraform and Juju, and specifically how you can use Terraform to manage applications as well as infrastructure with Juju. So first of all, I thought I'd go through what I'm going to cover in this presentation. The first thing is, why would you use Terraform with Juju? Then we're going to jump straight into sort of part one of the demo. We're going to be deploying into a development environment some of the components that you've seen in some of the previous presentations. While that's running, we'll then jump back to taking a look at the Juju Terraform provider in a bit more detail, then defining some of the resources that you would need to use with Terraform and Juju, specifically models, applications, integrations, which are the connections between different applications, and offers, which are, so if you have multiple models and you want to connect applications across those models, you can use offers to do that. We'll then look at how you would organize a Terraform plan repository to enable different deployment environments. And what I mean by different deployment environments here is like a dev, staging, and production environments. And then we'll jump back to part two of the demo. We'll test the environment that we've deployed in part one, and we'll look at some of the differences between those different types of environments. Okay, so first of all, why would you want to use Terraform with Juju? Well, Terraform is sort of known as an infrastructure as code tool, but actually with Juju, you can also use it to manage applications as code. It gives you a very nice way for developers and operations teams to collaborate via a Git repository that contains the Terraform configurations. And in terms of kind of the workflow, it gives you very repeatable deployments. So what I mean by that is that you can deploy from scratch something that is exactly the same, whether that's a staging environment, a production environment, or a development environment. But it's not just about that day one kind of initial deployment. It's also about being able to make predictable changes to that as your deployment changes over time. So sort of the day end story, basically. Terraform gives you a sort of Terraform plan, Terraform apply workflow where you see the differences that would be applied based on what configuration options or what values you've changed within your plans. So you can do things like scaling up your application, changing configuration, upgrading applications, whatever it may be. And also it gives you a way of managing production, as I say, staging and development environments in the same way, using the same tools. This kind of goes back to the idea of allowing devs and operation teams to collaborate well, having the same tool that they're using to deploy no matter where that is, and having visibility onto how production is deployed for developers and how development environments are deployed for operations people is extremely useful. Okay, so let's get started with a bit of a demo. So what I've done is to prepare a Git repository that has some Terraform plans for operatorinc.org. It's taken the pieces that you've seen in previous presentations, so the application itself, certificates, SSO, and observability. And it's put those all into a place where we can kind of mix and match based on what we want to deploy for different environments. We're going to deploy the development environment, and anyone who's looking at this can follow along. It's designed so that there are no secrets needed. So you can download this repository and give it a try yourself. Also, just to say, if you've got any questions throughout this presentation, please feel free to ask in the chat. We've got folks on hand who'll be available to answer those as you have any questions. So yeah, we'll deploy into the development environment. We'll confirm firstly that there are no Juju models beforehand, and then we'll run our Terraform apply. We'll then confirm the model has been deployed and that applications are also being deployed, and then we'll go from there. Okay, so I'm just going to switch to a terminal here, and I've got the Terraform repository that I was mentioning deployed, and I've got a README here which sort of explains how you can do the same thing yourselves. So really, all I've done is deploy Juju 3 on MicroK8s locally. I've enabled the MetalLB add-on, and then in this repository there are 3 environments defined, as I've said. So there's dev, staging, and production, and we're going to deploy the development one. So these are the commands that we're going to do. But first of all, let's just confirm our current sort of setup. So as you can see here, we've just got MicroK8s installed. We've just got the controller model, which is used to sort of manage Juju itself, but we've got nothing other than that. So we're just going to change into the directory. We're running Terraform init, which pulls down the various different modules that are needed to actually run this plan. And now we can run Terraform plan. I'm just going to pipe that to less so that we can see the output. And this is basically telling us what it would do if we then run Terraform apply. So it's going to create a bunch of resources. All of the things with pluses next to them are things that are going to be created. So it's going to create a traffic application, a Zinc application, an integration between the two, and a model. So we've got 4 resources basically that we're going to create as a result of this. So let's just do that. So it kind of gives us the same output again, gives us a chance to review that, and then says, do we want to go ahead? And we'll say, yes, we do. Terraform is now making various API calls to the Juju controller to provision the resources that we've asked it to provision. And if we now run Terraform plan, we can see, okay, it's inspecting what it's done, and it's already done what we've asked it to do. So there's nothing for it to do now. So let's take a look at what's actually happened on the Juju side of things. We can see that we've got now a dev-zinc model. Let's switch to that model so that we can take a look at it. Dev-zinc, if I can type that okay. And then we can just run Juju status watch. Okay, and we can see that we've got our applications deploying. We've got the Zinc charm, we've got the traffic charm, we've got relations between the two. So this first one here is a relation between Zinc and traffic, and then some peer relations that the charms themselves define. Okay, so let's leave that cooking for a little bit, and we'll jump into a bit more details of the Terraform provider itself. So when you're getting started with the Terraform provider, the best place to look is really the documentation on the Terraform registry itself. That's the link there. It defines each of the resources and how to use them and the different options that you need. To get started with the Juju provider, you just define this snippet of Terraform configuration. And it's basically saying that we require a Terraform version greater than or equal to 1.4 because the Juju provider requires that version or later. And then it's saying we want the Juju provider defines the source and the version that we want, which is the latest published version. Okay, let's start looking at some of the resources that we need. So the first one is a model. So this is a snippet of Terraform configuration that says that you would define a Juju model resource, and you would give it a Terraform internal name of Zinc. And then we have some key value pairs that allow us to define various properties of that model. The first one, the name, is what the name of that deployed model in Juju would be. So in our case, it was dev Zinc. So we have dev-Zinc there. We can also define things like which cloud what name of cloud and what region of the cloud we want this to be deployed into. And we can also define various model configuration options. I've just chosen one here, which is the update status hook interval. The update status hook interval defines something that runs, and many charms use this hook to kind of reconcile status, check the health of an application, and update their status, as the name sort of suggests. By default, this is set to 5 minutes. Here we're setting it to 30 minutes. You can obviously set it to whatever you want. Some other kind of common things that you may want to set via model configuration are things like the logging settings for Juju debug log, or proxy settings. If you have, if you're deploying things into an environment that sits behind a proxy, and you need to define those proxy settings. Okay, so we've defined a model. We now need to define some applications to go into that model. Again, we just do that by declaring a Juju underscore application Terraform resource, and we give it a Terraform internal name, again, of Zinc. The name here is, again, we've got key value pairs, and the name here refers to what that will show up as in Juju status, so the name of the deployed application. Now here, there are sort of two ways of referring to the model that we want to deploy this into. We can refer to it by the internal Terraform name, assuming that this snippet is in the same sort of working directory as the previous snippet that we looked at. We can just refer to juju underscore model.zinc.name, or we can just have a string that is the name of that. Obviously, referring to it with that internal Terraform resource name means that if we're declaring this a bunch of different times for a bunch of different applications, and we then want to change the model, we only have to do that in one place. We then define the actual charm that we want to deploy and the channel that we want to deploy that from. We could also optionally define the specific revision of the charm that we want to deploy, or the series of the charm that we want to deploy. We're also defining here, or at least I'm showing how you would define a configuration option for a charm. This is actually just for the demo, because the Zinc charm itself is a very clean charm. It doesn't expose any configuration options. You don't need to configure anything for it. But if you were deploying a charm that exposed some configuration options and you wanted to define those, this is how you would do that. And you could obviously define as many of those as you like. There are some other things that you may want to define against an application that would be in a sort of similar syntax to these other items. Things like the number of units that you want to deploy, whether to expose the application or not, and whether to trust that application or not. So if this is a Kubernetes application, trust basically means that it gets a service token that allows it to talk to the Kubernetes API to make changes to various Kubernetes resources. Okay, so we've defined a model, we've defined an application. We would probably want to define other applications. We now also need to define an integration between applications, and this is how you would do that. Just a Terraform resource of Juju underscore integration, give it a kind of Terraform internal name, in this case, Zinc traffic public ingress, refer to the model that you want this to be deployed into. We're sort of, again, assuming this is in the same working directory as the previous snippets. So we can use the Terraform internal name to refer to that model. And similarly, for the two applications that we want to connect, we can refer to those by their Terraform internal names. So Juju application.zinc.name, Juju application.trafficpublic.name, and the endpoint between those two applications that we want to connect is the ingress endpoint. So that's what we're defining here. And then the last resource that we're going to look at is the offer. So this is for when you want to connect applications that are in one model to applications in another model. If we're deploying COS, the Economical Observability Stack, typically we would want to deploy that in a model of its own, and then we would want to use this offer to expose that to another application. So we just use the Juju underscore offer Terraform resource and give it an internal Terraform name of Grafana dashboard. We then define the model, application name, and endpoint that we want to expose for that offer. This offer can then be used in another model in the same way as an integration was defined. Okay, so what I'd mentioned in the sort of start of the demo that I created a Terraform repository that has the sort of configurations for what we've seen in some of the previous presentations. And I just wanted to give a bit of a visual explanation of how I've laid that out. So effectively what I've done is I've created modules for each of the different sort of components. So we've got a module for Zinc, we've got a module for certificates, for SSO, and for observability or JAAS. We can then define various environments, dev, staging, and prod, and we can define which modules those environments want to use. And those modules will also expose some variables that you can set when you're actually using them in particular places, so that you can, for instance, say, okay, in development I want 1 Zinc unit, in staging I want 2, and in production I want 3. You can also define different external URLs in each case. Now, obviously, these sort of differences are quite small. You may want to have much more kind of complicated differences between your different environments. But let's just take a quick look at that actual Terraform repository, just so I can kind of explain how that all fits together. So this is the README, and we'll come back to that when we continue with the demo. But you can see that we have the environments and modules directories. So within modules, we have a directory for each of the components. So for COS, we've defined all of the different things that are needed. So this is 450 lines of Terraform configuration. We're defining the model that we want. We're defining a number of different applications, the relations between them, and all the things that are needed for that. One interesting thing here to mention is just how the sort of variable side of things works. So we can say you can expose a variable here and just define what that variable is, and then later you can actually say what value you want to use for that variable. In this case, we can also do a similar thing for certificates. We're defining what we need for our certificates integration, and in this case, we've got some variables, some of which we're defining as, let me just make this screen a bit bigger just to make sure you can see it, as sensitive equals true. So this variable is an AWS access key that you need to be able to use the Route 53 certificates provider. So what we're saying is that this is a sensitive variable. Obviously, none of the actual values for this are in the Terraform configuration. There are kind of two ways of actually defining those variables or passing them to Terraform. You can set environment variables with a TF underscore prefix that Terraform knows to then use as these particular values, or you can pull them from a secret store like Vault. And by saying here sensitive equals true, when we run Terraform plan, and we'll see this in the second part of the demo, it masks that output in such a way that we can share that output with, widely. Basically, it makes sure that it's not showing that value, and that it's something that only people with access to that particular option can see. Okay, so we've seen the module side of it, and then here's the different environments. So for dev, it's very simple. We're just importing the Zinc module and defining the particular variables that we want for that. For production, and similarly for staging, it's a little bit more complex because we're pulling in the other modules as well. But you can see that it's quite a sort of clean, easy to compose approach, and you can mix and match and make things, change things as you need relatively easily. Okay, so yeah, let's get back to our demo. we're going to connect to the environment that we deployed and just confirm that we've got a successful deployment there. And then we'll take a quick look at Terraform plan for the staging and production deployments, just to show a little bit of how the secrets there are dealt with. Okay, so we're back in our terminal. We can see that the Juju model is now in active idle status. So that seems to suggest that everything is looking okay. To test the service, we're just going to run this command here, which so we've defined an external host name, but we don't have a real kind of DNS entry for that. So we're basically telling curl to resolve that host name to a particular IP. And as we can see from the output here, we get the actual contents of the of that there. Having said that, it's not very easy to see that in a terminal window. So let's take a look at that in a browser. And as you can see, here's our Zinc UI that confirms that we can get to that. Now, the way that has been possible is that I have already added the IP address of the load balancer here to my Etsy host file, so that my browser thinks that it's able, knows that that's the IP address to use for that particular host. Okay, so that's all fine. We've deployed our development environment. Just to give you a bit of an idea of the sort of change, day two changing workflow. Let's say that we've deployed this, but actually we want to make a change. We want to rather than having one Zinc unit, we want to scale up to 3. Obviously, if we were doing this in a real setting, that would this is a Git repository. Someone would be making a merge proposal against that Git repository or a pull request. That would then be reviewed, and as part of that review, you could have this output here, which sort of shows for you what Terraform would do if you were to apply this change. So it's inspecting the environment and it's confirming that the only change that it needs to make is this line here, basically. So it's changing the Juju application resource, the Zinc Juju application resource, and it's changing the number of units from 1 to 3. So that's sort of the workflow. We could then just do a Terraform apply, and we'd get 2 other units. Let's have a look at what would happen if we wanted to deploy staging or production. So first of all, I'm going to source some credentials that are needed to do that. Those are excluded from these credentials are excluded from the Terraform repository, because obviously we don't want to put secrets in a repository. You may also, as I say, be pulling these secrets from a Vault instance or some other secret store rather than just sourcing a file. And we then need to do a Terraform init here as well. As you can see, in this case, it's pulling in a few more modules than we were pulling in our development situation. It's pulling in certificates, COS and SSO, as well as Zinc. And we can now run Terraform plan here, and let's see what we get. Okay, so in this case, it looks a bit different. If we go all the way down to the bottom of the output, we can see, so you may remember previously we had 4 resources. We had the model, we had the Zinc application, the traffic public application, and the integration between those. In this case, we have 64. That's because we're defining all of the resources needed for SSO, for certificates, and for COS. We're defining a separate model for COS. So there's a lot of different resources that are being defined. And you may remember when we were looking at the Git repository and we looked at the certificates module, the AWS access key ID was defined as a sensitive variable. And so in our Terraform plan output, rather than showing us the actual value that it's going to apply, it's showing us that this is a sensitive value. So this goes back to the story where it means that we can share this output widely. Developers who may not have access to the production environment or the staging environment, because this is staging that we're deploying, would be able to, to see this output and say, yes, everything else looks fine. Assuming that those values are what they should be, then it all looks good. One other thing to just look at here, this is staging. We defined that we wanted 2 units here as part of our configuration. That's basically just this particular value in our variable declaration. Let's have a look at what we get if we do the same thing with production. So once again, we need to run Terraform init. It pulls in the same modules from the certificates, observability, SSO, and Zinc side of things, and then we run a Terraform plan. Similarly, here we get a lot of resources, 64 resources. Again, we're pulling in the same number of modules for this particular deployment as we were for staging, but in this case, we've defined three units that we want to be deployed. This is sort of just a fairly, like I say, this is a fairly trivial difference between our staging and production environments. There's just the number of units and the external host name that we want to use, but there may be many other things that we want to do, and this would just be a starting point of what things we wanted to define. Okay. All right, so you don't have deja vu. There's similar content here to some of the initial slides. What I'm trying to sort of say is I hope that I've been able to convince you of the benefits of using Terraform with Juju. These are what I think are the things that doing so bring. It gives you a way of managing infrastructure and applications as code. It gives developers and operations teams a way to collaborate effectively. It gives you repeatable deployments from scratch, predictable day-end changes, and it gives you a way of managing your production, staging, and development environments in the same way and with the same tools. Okay, that was all I had for this presentation. Thanks very much.
I'd just like to have a short, brief introduction into controlling your distributed workloads through JAAS. Moving on to the first slide. I thought it'd be good to start with what is a controller. And a controller is a container of sorts, a physical machine, and essentially a wrapper around all of your Juju estate that's deployed through this controller. The best way to think of a controller is generally it's the heart and entry point into Juju. And it enables you to interact with your models. And don't worry about models, we'll go over what they are and their relevance, particularly their primary relevance to this discussion and explanation around JAAS. So I guess we should move over to what is a model. A model is also another container of sorts. So if you think of it like this, a controller is a container around models, and a model is a container around applications. It's effectively a namespace for you to deploy your applications into. And typically, it would be a logical grouping of applications to denote a service. For example, I may have a shop, a store. It will need a database. Perhaps it'll need Redis for queuing, PubSub, whatever it may be. It might have some SaaS components for cross-model. And ultimately, all these things together denote my domain, my service, my application as a whole. And that's effectively what a model is. It's a place to put applications, specifically and usually when it's a logical grouping. So in the next slide, we can see The sort of architecture of this, I wouldn't say architecture, it's a bit more in depth along the lines, but an initial introduction, a brief overview. So here we have a cloud. This could be any cloud. Doesn't really matter which, whether that's K8s, AWS, MAAS, anything like that. And you probably noticed if a controller is a wrapper around models, why is there a model with a controller inside? A controller is an application, and as such, it needs to be scaled horizontally, vertically. And what happens with applications? They break. They're just prone to it, whether that's network, configuration, whatever it may be. So Juju has this idea that because a controller is an application, it can go in its own model, a special model, so to speak, called the controller model. And this model can be scaled, same way you would any application. You should never typically need to interact with this, but it's good to know it has its own model and it can be scaled for redundancy and resiliency. On the right side of this, we have our regular models. And what I mean by regular is our applications. If a service, so I may call my service, sellingcups.com, for example. I probably would have a selling cups model with my database, my application, my Redis, and everything else I need. Now, you can see there's a machine 1 and machine 2. We can deploy applications in a model to a single machine. We can have them all in one machine. Wouldn't be the best idea, but Juju doesn't have a particular consensus on how you should do your deployments and your infrastructure, but you could. Typically, we would deploy one application per machine and have as many machines as we need in the model as we see fit. There is no hard limit. You can go as high as you want. And the same goes for models and controllers. There's also no hard limit. You could have as many models in a controller as you'd like. But this brings a problem. The only way to interact with all your models is through a controller. And if you've only got one set of controllers here, and the controller breaks, as software can, you've lost access to your model. So that's one problem. And the next one is, let's say you had many models across multiple regions in, say, AWS, or many K8s clouds, or even across clouds. Let's say you had GCP and Azure, you wanted full 99.999% resiliency and redundancy. Why would you want it? Well, the reason you might want it is region isolation autonomy, greater control over recovery time, lower regional latency, and the list kind of goes on, right? Now, the problem we were just talking about earlier, if you had one controller over all of these regions and potentially clouds, and that controller goes down, the models cannot communicate with each other anymore. The applications won't be able to have their state stored anywhere, and you'll have a single point of failure, which is not good. So how do we get around this? Well, that's where Juju as a service comes in. And it's effectively horizontal scaling, but in a single pane of view. So Juju as a service comes in two components. You have a web application, which is just a GUI. And this GUI is also usable in normal Juju. And we'll get into why this is the case in a slide or two. And it's also another controller. Now, the application behind the scenes is called Jim, and it's actually a Juju controller, but a special one. So it's not quite the same, but we'll explain why it's not the same in a minute. Moving on to the next slide, we can see these could be all your clouds deployed, and you would very likely have a controller per each to increase your resiliency, redundancy, and failover and recovery times, and so forth. So let's see the controller in AWS, controller in MAAS, Azure, Kubernetes, many models. I mean, this is just one model, but you could have many. You probably would have many. And they're all covered by Juju. And then the next step is to figure out how to get all these controllers easily interactable with. In the minute, they're isolated, right? So we probably have a controller on all these, and you have to interact with them one by one individually. Your observability is one-on-one. Your model interaction, deployments, configuration, you have to go to each controller to interact. So effectively scaling across clouds and regions becomes difficult. Not only do you have a single point of failure, your general administration is kind of hard. You're going to have to switch back and forth quite a lot and remember a lot more about what controllers where and how it's configured and so, whatnot, so forth. So let's move into what JAAS is and how it can help. So Jim, which is acting as a Juju controller itself, and remember it's the back end to the GUI, which denotes JAAS, Juju as a service. It's a means to view all of your models and controllers and clouds, etc. But primarily models in one place. And it acts so by being a proxy. So in the normal instance of having a controller in many models, it's fine. When you've got two controllers, you have to switch between the controllers to see the models, and that's not so fine. And as this scales, and let's say you have 10 regions, there'll be 10 controllers to interact with. What JAAS does is registers the controller with itself and acts on behalf of another controller. So all that controller's models become JAAS's models. And as a user, then you only care about is what clouds are available to JAAS. You don't have to care about the resiliency, redundancy, failover. None of that matters anymore. All you care about is I have Juju, CLI, GUI, whatever it may be, and here is my JAAS deployment. And I can interact with all my models across the board from a single pane. Now, moving on to the next image, it demonstrates it a little bit better. Again, it's one controller per each. It's just for demonstration's sake. This in AWS, you probably will have 10 controllers per region. But we can see here, the IT admins and SREs may use the dashboard. Very likely the CLI too, possibly. They may even have some automation scripts. And then we can also see the CLI, robotic users, CI processes would primarily and only interact with the API. And what this enables us is JAAS will go like this. And here's the flow. You'll have your CLI talk to Jim. And Jim, acting as a controller, can talk directly to the Juju CLI. Then what Jim will do is say, right, for this model and what you're trying to do, for this action, what controller does that belong to? So Jim will figure that out. And then it'll say what model, and that controller will find the model. And then that model will find that application. And all of a sudden, you don't have to switch between controllers. It's all in a single pane. And it's kind of transparent, right? You can see the cloud, you can see the model and the applications. And you no longer care about the controllers. You just care about JAAS. And that is, in essence, the heart and the message trying to be portrayed by Juju as a service. So I thought it would be a good idea to have a small demonstration of the dashboard variant of JAAS. I would have gone through a CLI, but it would have taken a little bit longer, and also buttons are a bit more fun to click. If you have any questions, please fire them in the chat. But we'll move over and have a play with the dashboard. So here we have a deployment for the operator day. And this is where all the operator day applications have been deployed. This is slightly different. I've redeployed it and broke some things on purpose to demonstrate some of the features of the dashboard in JAAS. But here we have one controller, and we can see the cloud, the default controller, models, machines, applications, units, version, access. We can see the statuses, the units, the applications, and the machines. But this isn't really the thing we care about. Like I said earlier, JAAS is backed by Jim, Juju Intelligent Model Manager. So what we really care about are models, places where we deploy stuff and put applications. So moving over to models, we can see we have two models, COS and operator inc. And we'll describe what's here. So we can see the status of the models. I don't actually have any blocked models to demonstrate, but you can imagine there'd be a red button here. But here you can see your applications, units, machines. See the owner of the model. My colleague very kindly set this up. Thank you. The cloud, which is operator incs on EU West 2. So I know from this, it's Kubernetes cloud. And this Kubernetes deployment, this Microcates deployment, is on EU West 2 in AWS because I recognize the cloud names. I name this. But you can name your clouds whatever you like. And this is what I was trying to explain earlier. We no longer even care about controls. We just care about clouds and models. So I can create a model through Jim on any cloud that's available to it and deploy things to it. So if I wanted to deploy to GCP, I could. If I wanted to deploy to Azure, as long as I've got the cloud registered, I'll just say Juju add model. Azure Cloud 1, whatever we call it. And off we go. There's a model. I can deploy directly to that cloud. Are all the regions of AWS? Perhaps I wanted a controller per region. And this is what I was trying to emphasize earlier. Next one, we can see the credential that will be used to interact. But now it's going to be Alish's. Again, thank you to my colleague. And then here we can see what was last updated. Any change to the model at all. But if we go over here and see the access, we can see who's able to access it. At the moment, we have 4 users. And if we want to add a user, we can add them here. Now, as for the permissions, admin, write, and read, I won't go into too much depth, but on the Juju documentation, you can see how the that kind of trickles down to each command and what belongs where. But in a nutshell, is read, so you can get the status, see the applications, etc. Write, which allows you to modify the model configuration and run particular actions. Doesn't mean all actions. In admin, which can effectively do everything on the model, but not the controller. Going into a model, we can click just its name, and it's pretty clear. We can see all of the applications, but let's first see on the left. So if we want to model access again, the same panes here. The details about the model is here again, very nicely shown. It's all exactly the same, so the access controller, cloud version, and SLA. But additionally, now we can see the individual applications. See the status of them, the version, the scale, the store they came from, the revision, and any kind of messages that channel authors might have left for us. In this case, nobody's left us a message. If we go into an application, we can see the unit itself. There's only one unit in this case. We can see the status, charm, operating system, revision, message, no message again, and the provider, which is the cloud provider for this particular controls model. On the row here, we can see the workload, whether it's active or not, which means good, green, it's running. The agent, which is the model agent, the agent within the application itself, is it running? Is it doing something? No, it's just chilling there, it's idle. The machine it belongs to, the public address, the ports, and any messages that the author's left for us again. But what's interesting is we can click into it and see more details. The same as earlier, but there's no machines here because of the pods. So in a normal machine deployment, you'd see a bunch of machines. But going back, what we can do is click the application and click Run Action. And if we run this action, this will run the proxy endpoints, and it'll return a list of them. So we click Confirm, and then we can go to Action Logs, and ignore all the previous runs, and there's a lot. We can see the action when it run and when it completed. So less than a minute ago is us. And you can have multiple outputs, so standard out, standard error, out and error. Depends on the action author here, however they handle their action. They may only want to return an error. In this case, they want to return both. So you can click it, output, and then click result. And you can see exactly the proxy endpoints for the traffic charm here. There's a nice little copy to clipboard button. Going back, let's say we thought this charm isn't configured correctly. Well, what we can do is click Configure on the application itself and see all of the configuration values. And if you want to know the description of parameters, like it says here nicely, you can click it. And it'll show you the details, the same thing you'd see in the charm store. And then coming back to the model, we can see everything's running. And let's say I wanted to just see the raw status. Well, we have an interactive CLI, the same way you would do with your normal Juju CLI. So if we run status, we can see the status in the normal Juju way, right? The CLI that most people are particularly used to. So now we can see it's running here, and we can see this is clearly in line with this, the applications on the status that you would usually get. And I guess the final thing to show you is all these charms are integrated in some way, passing data between each other, making deployments easier. How do I know what's where? Well, up here is the integrations button. You can see all of your integrations, previously named relations. You can see the interface and the type. So we've got a couple of peer relations here for scaling purposes, a couple of providers. So they want to provide a relation to another charm. And all of these here, the requirers, require something from another charm. Could be, a DSN, connection string, an endpoint in this case. What is your endpoint for me to scrape? And I guess that's about it, really. The action logs are here. If you're curious, just get into them for another button. You don't have to just go to the application and click View Action Logs. You can just click View Action Logs, and it will display them all. I guess that's everything about JAAS. It's a short introduction. There's a lot more we could go into, but in the sake of time, my name is Alex Kilroy, and thank you.